how to find the inverse of a function. So first of all, just as a reminder, a function is a rule that finds a y value based on the x value that you input. It finds a dependent variable based on an independent variable that you put in, do whatever you have to do, out comes the dependent or y value. The inverse of a function is the opposite. It's a rule that finds the x value based on a particular y value that you input. I think that says the value, and it should be the y value. As an example, suppose there's a manufacturer that determines how wide its product is based on, so depending on, the temperature of the machine that they use. So it means that they would put a certain temperature, that would be like their x, and then they would be able to calculate or figure out the width of the product. But supposing they wanted a very specific width of a product, if they wanted that, and they had to work backwards to figure out what temperature to use, then that rule would be the inverse. In terms of the notation of an inverse, if the original function was named f of x, which frequently they are, its inverse is called f exponent -1 of x. It's called f to the -1 of x, or the inverse of f of x. And if the original was called y, it would be its inverse would be called y to the exponent -1. Not all functions are called f of x. Some are called g of x, h of x, k of x, basically any letter of x. And for consistency, the same letter is used when you name its inverse, but with an exponent -1. So algebraically, which is the first thing we did in class, how to find the rule of an inverse is to, one, switch the location of the x and the y variables, isolate the y, and then write your answer using the proper notation. So here's a quick example of that. If the original function f of x is equal to 7x plus 50, the first thing I would do is rewrite that f of x as a y. And then step one in the procedure is to switch the x and the y. So where my x and y are, I'll switch their positions. I've put them in a different color just to highlight them. Where there was a y, there's an x, and vice versa. And now I'll isolate this y. So subtract 50 from both sides, divide by 7 on both sides. I've isolated the y. And step 3 is to write it using the proper notation. Because the original function was f of x, my inverse is f to the power -1 of x. And that isolated version, that is the inverse of the function. In example 2, it's a different type of function. The original function has a squared in it, but the steps are the same. It's just the order of operations that'll be a little different. I'll swap the x and the y, subtract 5 both sides. I want to isolate it, divide by 3. When I get down to this part here where I have a squared, I need to take the square root of both sides. It undoes the square here, and it introduces a square root on this side, and then I would add 1 to both sides. So that's isolated, and my final step is to write it as, in terms of its original name, this was g to the power -1 of x. One other thing to highlight, in this step here, where I'd had x minus 5 divided by -3, I changed here, instead of dividing by a -3, I changed it to divide by a +3, and to make sure that it remained equal, I changed the signs on top. So instead of x minus 5, I made it -x plus 5. It's as if I multiplied the top and bottom by -1. You don't have to do that. It's just a convention that I follow. It's the inverse there. And one final example, just because the math here is a little bit different, I would swap x and y, subtract 1 from both sides. Now at this point, because I want to isolate y, and y is at the bottom, in the denominator of this fraction, what I need to do is multiply both sides by y minus 4. When I multiply it on this side, they cancel out, and here they multiply up. And what I did in the next steps, I did it at the same time, then I divided both sides by x minus 1, because I again want the y by itself. It ends up here. What ends up happening is that I swap these two, their position. I end up with something that looks like this. So these x minus 1s cancel out, if you remember when we did rational expressions. And then I would add 4 to both sides. That's where I get the inverse of that function. The algebra there is a little bit different, but the idea is the same. And finally, finding an inverse graphically. One important property of an inverse of a function is that whatever point is on the original function, point has coordinates x, y, when I switch them, like when we switch the x and y, algebraically the yx is a point on the inverse of the function. So here's an example of how that works. If I asked you to graph the inverse of the function below, I could pick any point on the function. I'll pick one that has integer coordinates. This has coordinates -3 and 3. That means that when I switch those, that was the x and that was the y, when I swap them, it means the point 3, -3 is on the inverse. That's over here. And I would take a second point as well. I could do a third or fourth point. The point 0, 2 as an xy becomes, when I switch them, 2, 0, that's over here. And because that should be because the original was linear, the inverse is linear as well. That's the inverse of the function. And that is an intro to finding inverses.